Okay. Well, I thought I was recording. Okay. So 23. And I did it already. I'll just explain what I did. So a transformation, we talked about a rigid motion transformation keeps, we talked about it. Where did we talk about it? It keeps the sides, the same sides and the angles. How they say that is they preserve, it means keeps the same. Preserve the lengths and the angle measure. So it would have to be this one. Yeah, preserves length and angle measure. Okay, which rigid motion transformer could map ABCD to ABCD prime? So I like to, for this one, I like to focus on one point at a time. So I'm just going to focus on A. Let's see. So if A, and I'm going to go through the options. Or maybe I'll just look and see what would have to happen. No. Okay, translate 2 units down. So if I went 2 units down and then write 9 units, that's only going to go right there. Definitely not A. Translate 90 degrees, rotate 90 degrees and reflect over the y-axis. Rotate 90 degrees. So when they say 90 degrees rotation, we need more notes on this, right? 90-degree rotation. In order for something to be a 90-degree rotation, the general rule is you would take your x, oops, that's supposed to be a y. You would take your xy, your point, and what would happen, and let me just think, 90-degree rotation would move it down, and it would move it right, like about right there. So what happened is your x becomes, so your x becomes your y. So the x would go here, and your y goes where your x is, but then it's also the opposite. Okay, so that would go right there. And then across the y-axis, this is the y-axis, and that would put it over there, which is not where A is, so it can't be that. Reflect across the x-axis. Let's see, across the x-axis, this is the x-axis is right here. Boom, so it'd be down there. And then translate right, so reflect it. Let's see, if I did that, let me just look. If all the points would be about right there. Yeah, and then if I just moved right 9 units, this is looking good. Yep, I'm going to go with that one. So it reflected like that. And then, oh, it would be like right there, right? Yeah. And then it would move over. So that looks good. So C, okay, which transformation will not, this is the tricky thing, they say not map the figure onto itself. So let's see, if we did a reflection over the vertical line through the center, would it go back onto itself? Yes. If we did a horizontal line back onto itself, yes. So not this one, not this one. 180-degree rotation, that would just be like making the top go to the bottom, and that would still be the same thing. But 225 would make it go on a diagonal. Diagonal. Okay. If triangle STU is congruent to KLM, which of the following can you not conclude is true? So if they say statements like this, so triangle STU is congruent to triangle KLM, the order of these angles measure, because that would mean that S goes with K, T goes with L, and U goes with M. So this is good. S goes with K, that's good. T goes with L, that's good because that was the middle. And then the order with the lengths also. So TU, so those are the last two. Go with KLM, those are the last two, that would work. And then let's check if we said ST, that's those first two. Does it go with KM? No, because that's like the first and the last. So the one that it does not match, that one is okay, is D. Because you can't have the first two going with like the first and the last. Okay, what additional information is needed to show that those triangles are congruent by side, side, side? Well, it looks like we have this side would be the same thing as that side, but we don't know this one, and we don't know that one. So we would probably, if we're doing side, 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 we just need sides. So we can't have the ones with the angles because that has nothing to do with the sides. So the only one that's left, only sides. And we wanted that because it said side, 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 right? We don't even have to look at the details because there's only one that only had sides. Can you prove this postulate by the side angle side, the angle angle side, or both to prove the triangle right? Looks to me like if I had this angle and this angle, those are vertical angles, they would be the same. And all right triangles are the same. So we could have an angle, this side, and then the angle right there, matching this angle, this side, and this angle. So it'd have to be neither of those, because it'd have to be angle, side, angle. Okay. And then, based on the given information, what can you conclude and why? So it says that P is congruent to T. Oh, and then I can see while I'm at it that R would have to be the same thing as R because that's how it was in the figure. We can assume it if it looks, I mean, like if it's vertical angle, you can assume that. Then it says PR was the same thing as RT. So that's really tiny. But basically we have an angle, a side, and an angle. So it would have to be angle, side, angle. So do we have angle, side, angle? Oh, we have it right here, and we have it right there. So we have to check which one is the correct way of saying it. So let's see. P, Q goes up here. So down, up, and then inside. Is that the same thing as T, up, and then inside? So this one's looking good so far. And I'm just going to check PQR. And if I said RTS, that's like the wrong order. So it would have to be, because like R, and then like I start at the center and then go down and then to the over here. That doesn't work because it's out of order, right? You have to start like we started down, up on the wing, and then down at the center. So in the center, but they did center, down, and then wing. You can't do that. Okay, angle, side, angle. Which pair of triangles is congruent by angle, side, angle? So we want an angle, a side, and an angle. So let's see, we have an angle here, a side, and an angle, angle, side, angle. This one looks good. I'm just going to put a smiley like that. This one has a side, and an angle, so that would not be it. This one has an angle, and then a side, and the side is not between them, so it can't be that. And then the bottom one has a side, an angle, and a side. But we want angle, side, angle, because here's our angle, there's our side, and there's our angle, so it has to be C. Then name the theorem or postulate that lets you immediately conclude that those are congruent. Let's see. They're showing us right here. If we have one right angle right here, we'd have to assume that that's a right angle right there because that's what you have to do. And then you have this angle. So that's an angle, right? Here they're labeled with an angle. And then if they share the same side, then there'd be a side. So it'd be angle, side, angle, like that. Okay, and then what is the relationship between those two? They're BFFs. Okay, let's see. If we could say that they're congruent because I have, like S would go with M, right? They're both 70. And then N would have to go with R because they're both 60. So that would be an angle. The 2 is the side, and they both have the side. So we have an angle, and then we have angle, side, angle. We'd like this on this review, angle, side, angle. Okay, so they would be congruent. And what else do they want to say? A reflection over a vertical line. Looks like if I reflected it across that, would they be the same? Yeah, because they like switched places. So I would say vertical line. Yeah. Yep. A. Okay. Angle GC. Oh, wait. Given, it says AC. So I'm going to mark that. AC is the same thing as DF. What other information is needed to prove that the triangles are congruent by hypotenuse leg? So this that they gave us is the hypotenuse because it's the opposite of the right angle. So we would want to find a leg. So our leg options are this leg would have to go with that leg. So that would be AB would have to be the same thing as DE, or they can go the other way around. We don't need anything with angles. We just need legs. So it can't be this one or this one. Or the other legs would be the long ones. So we could say BC and EF. Is that there? AB to DE. Yep, that's D right there. Good. Cool. All right, I'm going to pause just to break the videos up.